As I joined the Ulrich lab in Frankfurt 2 years ago for my MD thesis, we could establish an optimized protocol for viral transduction of primary NK cells. While it is a relatively state-of-the-art to modify T or NK cell lines with viral vectors, it remained a difficult task to engineer primary NK cells. One main reason might be that NK cells are the first line and players of virus defenses and themselves only poorly infected with viruses. In our recent CAR-NK cell work, we compared two different viral transduction systems. On the one hand, the commonly used lentiviral transduction method, and on the other hand, the transduction with alpharetroviruses. Besides testing multiple viral vectors and a number of variables to the general transduction procedure, such as the MOI, time of transduction, activation stage of NK cells, and many others, we also analyzed the impact of viral pseudotyping glycoproteins for our two viral vector systems. Interestingly, we and others could show that the frequently used VSVG glycoprotein was outperformed by the use of RD114TR. This might be due to the specific receptors. The LDL receptor is known as the target of VSVG protein, but the surface expression in primary NK cells is very low. So whereas the expression of ASCT2, which is the specific one for RD114TR, and bamboon is much higher in primary NK cells. So in our work, we could reach similar and stable CAR expression efficiencies for the alpharetrovirus and the lentivirus. RD114TR pseudotype lenti and alpharetroviral vector systems performed equally well in transducing our primary NK cells and were significantly higher than using the classical VSVG lentiviral vectors. So, and the second important result I want to highlight is that we end up with a convincingly high cytotoxicity of engineered primary CD19 CAR-NK cells against different CD19 expressing BLL cells, such as SAB15, which is a cell line derived from CD19 positive BLL of an 8-year-old child. Even with low E/T ratios of 1:1, the killing capacity was significantly higher compared to non-transduced NK cells and reached levels up to 90% tumor lysis in a short time. So we believe that our transduction procedure using feeder cell-free IL-15 expanded primary NK cells and vectorflutin-1 as a transduction enhancer will allow us to generate a high number of functional anti-tumor CAR-NK cells. And this is a very promising advantage with regard to an off-the-shelf product and might open new possibilities for many other cancer immune therapies.